Yes. Hello, everybody. A great evening, guys. Hi, everyone. Hello, Shivam. I'm not seeing a lot of people on the chat. Yes. Hi, Kushika. Hi, Sravya. Yes. Hello, guys. How are you? Hi, Ganeshan. Okay. So, guys, last time we discussed about the oscillation part one. Okay. So, this time we're going to take up this one, the oscillation part two. Okay. And yes, Shakti, Abhishek, Meghna, everybody, guys, a great hi from my side. So I'll just repeat about the oscillations that we have done last time. So yes. So what was it? Acceleration. If I'm just talking about the SHM, okay. So I'm just considering a pendulum here. I'm just considering a pendulum here. So what you can see, whenever it is moving away from the extreme position, the acceleration has to be directly proportional to the displacement. Okay, displacement, you have to always measure it from the mean position, and it has to be always towards the mean position. Okay, so this is the main factor for the SHM. And obviously, if a motion is to be, if you just need to prove whether the given function is executing the given function is a simple harmonic motion or not, so first you have to just figure it out whether it is periodic or not. Then you have to look on these factors. You have to look up these constraints, like whether the acceleration is towards the mean position or not, or the acceleration is directly proportional to the displacement or not. Okay, so we are going to take up the question. Last time we have discussed a lot of things about the velocity, the acceleration, right, the energy and all that, right? So this time we are going to take up the questions directly. Okay, so yes, guys, so I'm going to take it up. So let me just start with the first question here. The oscillation of a body on a smooth horizontal surface is represented by the equation x is equals to a cos omega t. Okay, so guys, you can see here the displacement is a function of the cos. So means if you're just putting t equals to 0 here, so you are getting some displacement, isn't it? Because when you are putting t equals to 0 here, what you are getting, the x is coming out to be a, means the motion is going to start from the extreme position. Okay, or in the simpler term, if I'm making the pendulum here, so how it would be, this is the mean position, so the motion is going to start it from here. It is going from here, this is the starting point. Okay, that's why they have written it this one, the x equals to a cos omega t. Okay, so now x is the displacement at any time t, and the omega is the frequency of the oscillation. So we just need to figure it out, what would be the variation of the acceleration with respect to t. So how would you do that? We know that we can get the value of the acceleration from the displacement. Displacement is given as x equals to a cos omega t. So how would you do? You have to just calculate the velocity, just differentiate the given equation, that is a omega sine omega t, that to be the negative sign. For the acceleration, what you have to do, you just need to do the differentiation again, that you're getting it here, like in this way. Just a moment, this sine would become cos omega t, right? So acceleration here, I can see here, it is coming out to be minus a omega square cos omega t, or better you can write it in this way, that minus omega square x, right? So you can see here, this is also a function of cos, but here one negative sign is also being introduced, right? So the graph has to be like in this way, it has to be the similar graph whatever the cos has. Okay, but it going to start it from the minus a, right? This is how it is going to start. So which option should be the correct one, guys? You can see we do have the C option, where it is getting started from, the minus a, right? So this is the one, right, guys? Yes, because it is getting started from the positive one, we can just directly ignore it. Okay, this is going to start from the zero, and this is also going to start from zero. We are going to neglect these two options as well. So this has to be the correct one. So C is the right option, right? So this is how we have to do it. Fine. I guess it's pretty simple, right? So I'm going to take it up the next one. So here, the damping force of an oscillator is directly proportional to the velocity. Okay, what is the damping force? Means generally we do have the oscillations like in this way, like there is no loss of the energy, right? But what happens in the real life when you just put a pendulum and you're just dropping it, what is happening? Its amplitude keeps on decreasing, isn't it? So what is happening in this case? This is how it's going to be, right? So this is the damping force. This is how it goes. So here it says the force of the damping force is directly proportional to the velocity. What you have to do, you have to figure out the unit of the constant of proportionality. Whenever you are removing the proportionality sign, you have to introduce a constant, and that constant dimensions you need to just figure out, right? So F is equals to kV, right? And K is coming out to be F upon V, right? What is the dimension for the F? That is mass into acceleration, like kg meter per second square. Similarly, we do have velocity dimension for meter per second, isn't it? So we are getting kg second per second, sorry, right? So this one is the correct option. So yes, C. So yes, so guys, means this part has been has come from the portion where generally people just leave it. So you can just have a look on these things. Okay, so it's not like you have to just cover the major one topics. Okay, you have to just go through all the topics. Okay, so this is pretty simple, guys, right? Yes. So next one, out of the following functions representing the motion of a particle, which represents SHM. Okay, so these are the four functions given to us. So you just need to figure it out which one is performing the simple harmonic motion. So by looking directly, which all the options you can neglect directly? Can you just tell me? No, I mean I'm asking which one we can neglect it by looking at it. And for these things, guys, you just have a bit good command on the mathematics as well, because you can see here this function is nothing but a quadratic equation. So this is a quadratic equation. Okay, and to perform SHM, the person that the equation, the function should be periodic. This function is not periodic at all, right? So we can neglect directly this one. What about these three? Can we take this one? But we have to just make a single harmonic. These are the two given functions here. So can we just make it? We have to just do bit mathematics here. Okay, how? Just see it. See, y is given here. Y is sine omega t minus cos omega t, right? So what you can do, I can make it in this way, under root 2, and divide I'm going to do in this way. Right? Right? So y is this one. So what I can do is I can just keep under root outside, and I'm going to multiply this under root 1 upon under root 2 here as well as here. Okay? So you can see here under root 2, and this 1 upon under root I can write here as cos 45, or you can say pi by 4. This is sine omega t minus this is sine pi by 4, because cos and sine both have the same value at the pi by 4, right? So cos omega t, right? So this going to be, which formula it is? Sine a minus b. So you can write here as sine omega t minus pi by 4, isn't it? Any doubt in this, guys, till this point? So now we have converted that particular function into a single harmonic, right? And this is a function that is periodic as well as it has just a phase of pi by 4. That's all. You can directly tell, yes, it is a SHM, or you can prove it. How we are going to do it? Just a moment. How we are going to do it? See, y is equals to this. We have got it, sine omega t minus pi by 4. What you can do is you can just calculate the velocity or probably the acceleration as well. So in the first one, I'm going to write it here as under root 2 omega cos omega t minus pi by 4. And once you just do the double derivative of it, means d square y upon dt square. Okay, what you are going to do, this is t, guys. Okay, so this would be under root 2 omega square minus sine omega t minus pi by 4. So how I'm going to write this one? This is nothing but the acceleration. This entire quantity, sine and the under root 2 is nothing but the x, and we are getting the form of minus omega square x, isn't it? And this condition is being followed by the function which are performing the SHM, so we can pick up this one, the first one. Okay, and guys, you can do the same activity. This one is performing the SHM, and you can do the same method for this one as well, and you will get, again, you have to just prove it like minus omega square x. Okay, so I'm telling you, so these are the two options which will be correct here. Okay, so first and third has to be the SHM. This is not a periodic function. Okay, this won't be like in this way, because it's going to take a lot of time. You have to just check each and every options here. So I'm just telling you directly, I have done this one for as an example, so you guys can do it for the other one as well, whether this condition is being satisfied or not, and it should be periodic at the first moment, right? So according to this, so one and the third has to be the correct one. Okay, these are the two options which are performing the SHM. Guys, any doubt in this? This is how you just need to do some mathematics here. You have to just play with the mathematics. You have to just play with the function. How can you make it in a single harmonic, and later on you can just do it this condition, the a equals to minus omega square x, whether it is being satisfied or not. You just can then you can make a conclusion whether it is an SHM or not. Okay, fine. So yes, guys, just a moment. Yeah, yes, so I do have another question here. The period of an oscillation of mass m suspended from a spring of negligible mass. Okay, this is a spring here, and the mass is being attached here. Okay, so the time period here, you know what is the time period? We have calculated last time, 2 pi under root m upon k, right? And when we have attached another mass, okay, what would be the time period? It's pretty simple, guys, right? So time period has to be in this way, 2 pi under root, this will become m plus m, so it would be 2m, right? So what you can do is you can just divide both the equation, and what you are getting here, let me just write it here. This is, I guess, the simplest question that we have got for all. So this is going to be under root m upon 2m. So this will get cancelled out, and t dash is coming out to be t under root 2. Okay. See, Donnie, this is just like simple. You just need to write the formula for the time period whenever for a spring block system. So time period of a spring block system is t equals to 2 pi under root m by k. It just depends on the mass and the spring constant. Okay, so when you are attaching another mass, the mass would get doubled, isn't it? There would be any effect, only the mass will get doubled. So what you have to do is you have to just take the ratio. That's all. That's pretty simple, isn't it? So this D has to be the correct one here. Okay, so let me take another question here. Yes, which of the following equations of the motion represents simple harmonic motion? This time you guys have to answer it. I have already told you how it would be, how you have to do it. So can you just do it? I'm just waiting for your response, guys. Okay, can we just look at the functions one by one? Acceleration here is a function of x square that going to be parabolic, right? So we cannot just take this one. This we cannot take this one. Acceleration, I'm going to take it up later on, not now. First, I'm going to take up all the option which I need to just discard. Okay, so acceleration equals to kx plus a. Here it is a positive. Here it is, the plus sign says that the acceleration is not towards the mean position. Okay, it is away from the mean position, so we have to discard this one as well. Again, this is again the kx, again you can see again a positive one, so again we have to just discard it. The only option we can take it up is the acceleration minus kx plus a. So guys, here the a is also extra. Whenever we are putting a constant, it does not affect our equation. Okay, so all you have to just look at it is see the minus kx thing. Okay, so this has to be the correct one. By looking at it, you can just answer it. Okay, so yes guys, yeah, so this one, a simple pendulum performs simple harmonic motion about x equals to 0. So I'm going to make a number line here. So this is going to be x equals to 0, right? And with an amplitude a. So I'm going to take this one as extreme position, right? So this has to be the a. Okay, and its time period is given as t. Okay, and the speed of the pendulum at x equals to a by 2, when this guy means this pendulum is going in this direction. Okay, this pendulum is going in this direction. Suppose I'm going to just sketch it here. Okay, at x equals to a by 2, at x equals to a by 2, you just need to figure out the velocity. And what I have to tell you, what I had tell you before, means in the oscillations part 1, that we do have a relation v is equals to omega under root a square minus x square. That's what you have to do. So velocity, we need to figure it out. This is omega. What is a square? What would be the displacement at x equals to a by 2? That is given, a by 2 only, right? So a by 2 square. So this is going to be omega under root 4a square minus a square upon 4, right? So now what you can do, that v is coming out to be omega under root 3a upon 2. And further you can extend the omega part, that is going to be 2 pi under root 3a upon 2, and that t as well, because omega is what? Omega is 2 pi upon t, right? So here 2 will get cancelled out, and the velocity we are getting here is pi under root 3a upon t. So this is the velocity we are getting for at x equals to a by 2. Okay. Okay, so which option should be the correct one? Pi root 3a upon t. So the d is looking very great out of all these options, so we need to just pick it up, this one. Okay, fine. So yeah guys, that's all for today. So I'm going to wind up now. And guys, this topic was one of the important topics as well. So, and definitely you're getting one numerical, okay, probably on the SHM, or maybe upon these velocities or the time period or the frequencies. Okay, so that's all guys. Thank you for watching the session, and we'll be meeting up in the next one with a new topic. Thank you so much. Till then, just take care. Bye bye.